Yo. What's happening, people? How's it all going? Oh, man, what a day. Ooh, T2, Blue Mountains. Very nice choice. I, just like you, know that hacking without tea is very uncivilized, and so I have I'm back to my green, my Dong Ding Oolong for tonight, so no regrets on that front. Apologies for not streaming yesterday. It was my intent to do it yesterday, but I was feeling pretty cooked, and there was another World Cup climbing bouldering final on live streaming from China in Wujiang, so I thought I'd have a break and enjoy watching that with the missus and spare you of my company. Good evening, Smash. How are you, buddy? And Rasta, good morning to you, sir. Now, I don't know how many will get tagging along this evening. It is a Monday, and most people tend to be cooked by Mondays. Because, you know, Mondays, which I totally get. But with a bit of luck, we'll get a few regulars, we'll get some randoms, but we'll make progress regardless. So I hope all is well in your respective neighborhoods. We are going to kick into some code pretty much straight away. We are going to be looking at some configuration related bits and pieces as well. However, before we get started on that, we're going to rejig a little bit of the code that we've written, just so that it sort of has a sensible structure to it. So, how are we going to do that? Did anyone have any questions, by the way, from the previous streams? Oh, and tonight, because it's the 7th one, this is the seventh stream in 13 or 14 days? 14 days. And so, that means hopefully we'll hit Twitch affiliate by the end of this one. So that would be nice. That's been part of the goal. I love the randoms who find this stream. Yeah, it kind of makes me wonder how they do it. Hey, we've got 13 people viewing at the moment. I don't know whether they come in because of the hashtags or because of the science and technology category that we're streaming in. Who knows? But whoever they are welcome as long as they're not nasty. Alright, let's flick over to our VMware scene. Still got the blue screen of death behind me. I can't bring myself to remove it just yet. It still seems fitting for some reason. Yeah, well, you know, it could well be weird to them, as weird as it is to the rest of us. Alright, so before we kick off, let's just rejig a couple of these things. So I want to start sort of pushing things into namespaces, so that we can sort of logically segregate bits of code rather than just having, you know, file after file appear in here. So let's, I'm going to start by creating a folder. And I'm just going to call this extensions. Can't remember whether that actually does, it does, it puts things on disk. So if I move all of the extensions into that folder, hopefully the files will go with it. Yep, they do. But what we need to do is, we need to add the namespace to the end of these so that they match. Could probably go ahead and what are we missing here? We've got to add, oops, that's not where I should do it. I should do it there, shouldn't I? That's pretty stupid. And then we're going to have to add a sort of reference to these areas in other areas of the code. Good evening, Jay. How are you? Atwolf, greetings to you. My reminder file, come on, man. I bleated about it on Discord. I've tweeted about it. Twitch notifications should have gone off. There's only so much I can do, right? Now, the other one I'm going to set up here, new folder. I'm going to call this Proto. And I'm going to put packets and TLVs in the Proto namespace. Do the same there. Now, somewhere in here they're going to expect these extensions, so let's make a habit of going using met.core.extensions. And that should satiate the compiler, and we should be able to build, but we'll see a failure probably in program.cs. Oh yeah. We're going to have to add using met.core.proto in here as well. Actually, is it in here we need it? We probably don't need it in here. We would need it in the... Oh yeah, we do. Yep, we do. Let's take a copy of that. We'll also put it in... The binary writer and reader both need it. So we'll shove it in there and obviously in the enumeration extensions. What's going on now? Ah yes, here we go. So we're back to the issue that I said. So using met.core.proto, and that should hopefully resolve all, maybe but one of the compiler issues. What do we got? Oh no, that's all of them. That's a breakpoint that we can see there. All right. So we're back to where we were. Okay. So that's, I just wanted to sort of logically segregate things, and from here we're going to start adding more and more and more to this stuff. You being Twitch's, it's a reminder, don't trigger for me. That's strange. Excellent, Jay, good to hear it, mate. Hey Vikram, welcome to the stream again, buddy. Thanks for joining in. Okay, so at this point, what I'd really like to do is start diving into some configuration, and that configuration maps to session related information, it maps to transport configuration, it maps to a bunch of other things as well, including extensions. So what I'd like to start doing is sort of going through the process of supporting the configuration that's generated out of Metasploit, because when we start doing things like staging, we are straight away we're going to have the need to parse configuration, and there's a couple of little quirks that we're going to want to think about along the way as well. Anyway, let's move on now. I guess what else we could be doing at this point is making sure that we create metserv for .NET 4, but I'm not at this point yet. I think we can do a little bit more work before we start working on creating our sort of first version of the .NET 4.0 binaries. Jay, you having any... yes, that's a good point. I do have some dark. 90% lint again. I had it sitting on my desk ready to go and I had forgotten about it. So thank you for the reminder. Let's crack a little bit of this to go with our green tea. Cheers. Very good. I'm a spoiled man, that's for sure. Very spoiled. Okay. Now, as far as the sort of core session related stuff and transports and whatnot go, we're going to start with just session information, but we're going to have a look at how... Yeah, I'm pretty happy with the soundtrack too, Archbishop. We're going to have a look at what Metasploit does to generate the configuration, right? So if we have a look at, we'll go modules, payloads, let's have a look, stages, windows. I'm opening these in different tabs just in case. You'll see we'll have, let's start with something really simple, reverse TCP. So if we have a look here, you can see we include a bunch of stuff. Core payload, Windows, reverse TCP, and here all we're doing is we're defining some sort of high-level metadata around what the payload looks like. But you'll see we pretty much only, other than specifying some module-specific code, including things like conventions and architectures, we include the core stuff out of this MSF core payload reverse TCP. You can only find 85% in the UK. Wow, that's interesting, man. You're missing out, because I mean, I'm not a big fan of super sweet chocolate anyway, but 90% is bang on for me. A little dark, it just feels a little bit too, I don't know, palate or something, but I find 90% to be perfect. So if you can dig it up, man, you really should. Righto, so let's dive into lib. I want to go lib, core, sorry, is it, hang on. Where are we? MSF core, not libcore. Sorry, my bad. Lib. Oh no, that's the same path. Libmsf core payload. We'll dive into Windows for now, just to keep it along the same lines, and we'll have a look at reverse TCP. Here we go. So this is where we're going to find some interesting stuff. Now you'll notice that we include, so we've got transport configuration, we've got stuff to do with sending UUIDs and block APIs and exit funcs and all this other magic gubbins. But the bit that we're really interested in is things like this, right? You'll see how we've got an implementation here for transport config. And that's like an overload that the framework calls to get configuration that's specific to this particular transport. So there should be a definition of this somewhere. Let's have a look. Okay, so transport config, here we go. So this is where all the transport configuration code lives. And you'll see, the first one there, pardon me, what we do when we generate a configuration that maps to a reverse TCP, we actually do the same thing for bind, but we basically add an L host, which will specify the value that's called back. So if we look at bind TCP, we're just saying we have a TCP scheme, we have L host, L port, and we basically include a bunch of ops that specify timeout configuration, and that's specific to the transport as well, because there are timeouts that are specific. Okay, so these are all specific to transport configuration. But the important thing to note here is that, let's go back to this function here. Transport config is what's called. So what I want to see is the definition, or the part of the code where the transport config is actually invoked. So you see there'll be a bunch of payloads here that all specify their own transport config, but something calls it. So let's see. We might even have to get smarter with some greppage. Here we go. Stages, of course, it's a stage. Forgot about that. Now, ignore all this stuff just for now, because that's actually specific to this particular payload. But you'll see here that a transport configuration is generated and passed down to this stage payload option. Now, what I'm going to do just quickly is pop back up to stages, and we'll go into the Windows implementation. Devesh, hello! Thanks for coming in, mate. It's nice to see you here as well. How's it going? I hope you're living the dream in your part of the world. I'm really glad to see that you managed to come along, buddy. Cheers to you. I hope you've got your tea. So good. Okay. What do we got going on here? So, this particular piece of code here is responsible for configuring the process of loading Meterpreter as a stage, and you can see that it's using this base. We've got base sessions, Meterpreter x86 win, we've got the Meterpreter loader, and we've got Meterpreter options. So you can see this code kind of all over the place. You've watched all the YouTube vids. Oh man, that's awesome. I'm so happy to hear that. Thank you. Please hit me up with any questions if you have them along the way, mate. We'll do our best to answer as we go. So let's go back to, we want to have a look at Meterpreter options, because this is where a lot of the stuff is going to live. That author name looks familiar for some reason. Scape. Yeah, funny that, hey. Scape, Stephen Fewer. So Scape, the original Meterpreter man, Stephen Fewer, who's responsible for a good deal of stager work and reflective DLL injection. And me, because I fixed a bunch of stuff in these areas before. Hey Peleus, welcome to the stream, buddy. Okay, so let's go back up here, because what we're going to do is we want to go back to core, don't we? No, we want to go base sessions, libmsf, base. See, I'm still trying to remember where all these bits of code live. There's so much code all over the place. So we'll grab that, and we'll grab Meterpreter x86 win as well. We'll have a look at that. Righto, let's see if we've got anything in here that's interesting. At the moment, there's nothing here that stands out that's specific to what we're trying to do that I want to highlight, because this is all magic wiring that goes on behind the scenes. I'm looking for the stuff that generates the configuration. That's the most important part at this point. And it looks like neither of those things are what we're looking for. So I'm going to close that off to avoid any confusion. And instead, let's have a look at the Meterpreter loader. I think that's where it's going to be, to be honest, anyway. Lib MSF core payload. I'll be turning 16 this June. I really want to get an exploit dev after watching your vids. Oh, that's awesome, man. Well, I wish you the best of luck. It's a very fun area. I don't even remember being 16. I turned 40 in December, Rustamouse. So don't talk to me about age, my friend. Windows. Is that what it was? Meterpreter loader. There it is. This is the thing that loads the meterps. And I think this is where we're going to find what we're looking for. So ignore all these conventions and blah, blah, blah. What we're looking for is, there we go, generate config. Hey Vendetta, thanks for coming in. Keith Nicholas, greetings to you too, sir. It's lovely to see you all here. We've already got 23 people on a Monday night. I am amazed. It's fantastic. So, a couple of things I really want to focus on in here, right? There's some magic functions that need to be overloaded, and you'll see this stage payload function that gets called by the framework and says, we want you to generate a blob of data that we're just going to send down the current wire. And that wire might be reverse HTTPS, it might be reverse TCP, it might be all of those things. But you see what we do is we stage Meterp itself and we generate configuration. You'll see that using just the plus operator here, we're taking a blob of binary and a blob of binary and we're sticking it together. I look at least 10 years younger than you are. Thank you, Jay. Flattery will get you everywhere, my friend. To be fair, I don't think I look like I'm 40. I certainly don't behave like I'm 40, but I am. I am the big 40, and I'm loud and proud. Hey, Kilix, thanks for coming in, dude. Nice to see you again. Okay, so when we stage Meterp in this scenario, when we stage the payload, so remember, stage payload is a generic function that's invoked on whatever payloads it is that we're currently staging. It could be a shell payload, it could be, arbitrary stuff. So we need to be able to stage the payload, and you'll see that the implementation of this is staging Meterpreter along with the configuration. So stage Meterp is actually really simple. We take metserv, and you'll see we're looking at the 32-bit Meterpreter loader here, and it pulls the x86 version of metserv off disk. And from there, we specify some options for generating assembly. We've got a new follower, Figs. Thanks, dude. Thanks for the follow, I appreciate that. And you'll see that when we generate these asymops, we basically say, go ahead and generate some assembly for me based on these operations, okay? And that's just doing some magic wiring so that when metserv is actually pulled in, everything works as expected, okay? So, the bootstrap code is basically the assembly code that's generated, which is this asm just here. Then we use metasm to generate proper shellcode on the fly. We encode it as a string. Do a very basic sanity check to make sure that the size of the bootstrapper isn't too big, because we've got to cram this at the start of the DLL to make it look like a DOS header. And then we return the DLL. So that's how... on the fly, metserv is loaded, its header is patched, and then that's basically it. So you see the assembly here. This is for the start of the bootstrapper. So M and Z makes it look like a PE header, and then it just does a little bit of adjusting, does some math, and then invokes DLL main using reflective DLL injection. So invokes, you'll see this, invoke the reflective loader, which is that. And then you invoke DLL main. But we're sort of getting into the weeds. But this is the interesting bit here. So we're going to emulate a lot of what we're seeing here when we generate the configuration. And in fact, what I am going to do for our sort of first pass of making all this work is we're going to connect to a reverse TCP Windows endpoint and attempt to parse the configuration that comes off the wire. So... Reverse It TV. Your name came up in my feed recently for some reason. Thank you very much for coming along. I think it was it YouTube? I think I saw you appear on YouTube. But yeah, thanks. Hey, the bull. How you going? I think, yeah, good evening to you, morning. Whereabouts are you based? I'm definitely in the evening, so hence my tea. Sun is shining. It's noon here. Where can I see today's topic, or would you mind telling you? Okay, so today's topic is we're going to start handling session configuration, which is going to come back from a listener when we first connect. Okay, so that's what that's about. It's also going to be part of stageless payloads. East Coast US, cool, man. Yeah, it must be either very, very late or very, very early for you. You are most welcome. Reverse it. Okay, so this is what we're going to do. You'll see for each type of payload, in this case, it's a Meterpreter payload, you'll see that we specify a bunch of stuff, right? Germany, far out. Germany. Have never been to Germany. I'd love to go to Germany. It looks beautiful. And the rock climbing there is fantastic. So because of the way that staged payloads work, you'll see that we don't throw things down the wire at the time, such as extensions. So when a Meterpreter payload is first staged, we don't actually send any extra extensions down the wire. That's added sort of later on. But the really key points to note are this. We specify the architecture because that has to go into what's called the UUID. We tend to start with we specify a null session GUID for stageless payloads, but we'll ignore that for now. Exit func is important because for binary payloads, we need to be able to exit the process in the correct way. We may need to emulate this in .NET as well. Expiration refers to the actual session limit. So that means you might start your Meterpreter payload at a particular time. Pardon me. And you want to say, I only want you to last for 3 days or 3 weeks or 3 months. And so there is a session expiration timeout option, which allows you to specify how long you want your Meterpreter session to run for. Regardless of transports, regardless of success, it will time out after a period of time, and that's what it is. So if you go with default, I think it's 4 weeks. I can't remember exactly, but it might be longer, it might be shorter, or it might even be 2 weeks. If anyone knows on stream, please let me know. But yeah, there is a default, and it's a number of weeks. Why do we not send more payloads down the wire? Because what we want to do when we first stage is we want to send as little information down the wire to make Meterpreter work so that we can bootstrap encryption, and then everything else can go across the wire encrypted. So what we're sending in stage land here right now, this stuff is not encrypted, it's plain text. Okay? So we want as small amount of going down in plain text as possible. So it's basically just Meterpreter, like metserv.dll, and the configuration that will bootstrap it. Once that's gone down the wire, Meterpreter will load up, negotiate encryption, and then everything else, all of the other extensions, should get sent down over an encrypted channel. Hopefully that answers your question. India, excellent. Serbia, I didn't know that. Australia, hello Menz, thanks for coming in. B-Man, I knew you were Australian too. Keith Nicholas, you're in New Zealand, fantastic. It's North or South Island, mate? Do you love me a bit of the South Island? Auckland, yeah, fair enough. I haven't been to Auckland yet, I need to go. Lovely part of the world though, I hear. Okay, so once we've created these configuration options, we then say, hey, we want to go and create a configuration that matches these options. Now, this is where the magic happens, okay, inside this Rex payload Meterpreter config. And you'll see we get this configuration, and then we call 2B, which is just to binary. All right, so that is in, where is that? That's in Rex payloads Meterpreter config. So we go all the way back to the root. I'll close that off now. Lib Rex, come on, payloads Meterpreter config. Here we go. Now there's a bit of magic in here, okay, but let's go to the start. Hang on, where is it? I think once we give it the ops, we basically just store them. Here we go, ops. Yep, there you go. So we just store some options here, right? And then when we call 2B, which I think is down the bottom here, config block. Hang on, 2B. Aha. So when we say to binary, we just want to create this config block. So the config block starts down here. Okay. Now the first thing that we do when we generate configuration is we generate session options. So we go to the function that generates the session. So to begin with, we get a UUID. A UUID is it 8 bytes or is it 16 bytes? Can't remember. We will get that information from other sources, I'm sure. UA, so these are all to do with other bits and pieces. Then we get the exit func. And then depending on whether we are supposed to specify a null session GUID or generate one, we specify 16 bytes of either null or an actual GUID. So you see we generate one here. 16, it is 16 bytes. Thank you, you're all wonderful people. And then from there we get this session data, which is, it starts off with the socket handle, which the funny thing is about this configuration is the more and more we use it on different platforms, the more and more this first value actually means nothing. So we'll just ignore that for now, because that is either patched by the stage or it's completely ignored, right? Then, yeah, I know. Exit function identifier, which we probably still will use. Session expiry, UUID, followed by the session GUID, and we basically just pack that into a byte stream. Okay? So, we need to be able to parse this as well. Okay? And what we might do is wrap this up into probably just a, I don't know, let's go with, maybe what we'll do is we'll create a session object in our code, and that session object's going to contain the things like the UUID, the session GUID, references to the transports, that sort of thing. And if that becomes an unnecessary object, we can merge it sort of back into the root of what I am going to be calling the server, effectively. So let's add a new class. I'm going to call this session. And I'm going to add another new class. Actually, we can do it this way. Class server. I know that's a bit of a lame name, but the Meterpreter server is sort of the core part of this whole blob of code, right? So we've got a session and we've got a server. Okay. Now the session, for now what I'm doing is I'm marking the classes as public, although we won't be maintaining this long term, right? Okay. Now, our server will have a session, okay? But I'm not going to make, because the server is effectively the root object, we're just going to have it as a private member, okay? Now, when the Meterpreter instance is loaded, we've somehow got to deserialize a session. And we'll probably end up doing that with a binary reader in the same way that we did with the TLV packets, okay? Now, one option is to say, well, let's have it so that it bootstraps itself through a binary reader, or what we can do, in fact, this is something that's worth discussion. Oh, I don't know why it keeps doing this. Must be something crazy going on in the file system. You see, we've got a bunch of overloaded constructors that take different parameters. Given that we're doing that, we might just sort of stick with that particular method, right? So we've got a public session and we take a binary reader. Okay. Now, the session, as we know, has a UUID, a GUID, and those pack options look like someone just smashed the keyboard. Yeah, I tell you what, man, packing is just horrible. Just horrible. I hate it. I hate reading it. I hate writing it. It just feels filthy. Now, we are going to have public properties for this. So what we're going to do is we're going to have a public. Now, in .NET, we actually have a GUID type. Question is, I think it's actually a struct, so to speak, a value type rather than a reference type. But we don't actually do anything smart with GUIDs. So we don't need the functionality of GUIDs. All we need are the bytes. So instead, I'm going to have a byte array, which is the session GUID. Actually, we don't need to specify session GUID, given that it is a GUID already. It is in the session. So let's just do public getters and setters for now. We're going to need a UUID, which is actually not the same thing. The UUID is an encoded blob that says something about this particular architecture. Is there any easy way or least pain in the rear to do what? To do what I think dealing with byte arrays to begin with is what makes the most sense. Excuse me. Okay, so going back to our configuration block, we hit our session block first, and we generate basically 0. So in other words, we're going to skip the first 4 bytes. Skip the first 4 bytes because this includes something that we don't need. Okay. Actually, we won't even say that. This contains a handle that .NET Meterpreter doesn't care about. All right, so we'll just go reader.read dword. Now that's an extension method, so we're going to need to include the extensions. Oops. Okay. So we're going to skip the socket handle. Immediately after that, we have the exit func. Now I am going to store the exit func, but we're not going to make it. Oh, actually, we might make it public. Public uint 32 get set. Okay. So then we can say this.exitfunc equals reader.read dword. Okay, so that should give us the exit func. All right. Is this session class getting a binary reader that has already been de-XOR'd? Yes. Now, actually bear in mind that this, because what we're dealing with here at Wolf, I actually said yes and I'm incorrect. The answer is that XORing isn't relevant at this point. So nothing is actually XOR'd. This is just, we're taking the DLL, we're generating a config block, we're sending it down the wire. The assumption here is that stages are really dumb, and unless you enable things like stage encoding, then you won't actually get any encoding stubs baked in. So that's actually getting ahead of ourselves a little bit here. We've got to assume that whatever's coming down the wire right now is raw. We don't need to XOR anything. Okay, hopefully that makes sense. Is there any functionality which makes the Meterpreter payload make continuous attempts to the server at regular intervals in case the server is offline? Yes, there most certainly is, Devesh. That was something that was implemented, I think it was 2015, where we baked in support for extra transports and transport recovery. So if for example, you end up with a network split or something, then it will attempt to reconnect to you based on retry weights, retry totals, expiration timeouts, all that sort of stuff. Oh, I thought the session UID was this comes in at the start of the TLV packet stuff when the XOR. No. That's this. The TLV stuff that we've done is in place for when Meterpreter has actually been staged. This right now is the process of staging. Hopefully that makes sense. So this is before we can even start parsing TLV packets, before we've even really established communications. Okay? Yeah, sorry, mate. I should have made that clear. So what we're doing now is we've built some code that can parse TLV packets. Now we've got to step back and we've got to go, okay, how do we get that code running? So to get that code running, we need to send a copy of metserv DLL down to the app that we've owned. It needs to bootstrap it and then bootstrap itself from the config that's gone down the wire with it. So going back to, hang on, where is it here? Is this the one? Yes, going back here, you can see Staged Meterpreter. Staged Meterpreter just basically takes the DLL and patches it a little bit. Then it generates config. So we've got a big stream of bytes in one massive chunk that is actually a DLL and the configuration. And that's going to get sent down the wire, right? So at the other end, we need to take the first chunk, which is the DLL, and in our case, it's going to be a .NET DLL. We're going to take that chunk, and we're going to load that using assembly.load, right? We're going to wire that type into the current running CLR, and then from there, we're going to get a handle to a new Meterpreter server, and we're going to parse it, basically either the byte array that contains the configuration, or a binary reader that contains the configuration. And from there, it'll bootstrap itself in config, and after that, TLV packets can start going down the wire. Yeah, there are a couple of Rocket League tunes that keep appearing. So anyway, hopefully that answers your question. Okay. So going back here, we've got that, the exit func. Now, session expiry is another D word. It's the number of seconds, right? Expiry. Now, the question here is, like we're going to get a uint32, but we need to convert that to a date time. So that's like a, so let me just check that. Session expiry, ops expiration. Let's search for this because I think, here we go. So session expiration timeout, that's right. Let's have a look at what the default for that is. I don't even know where it's initialized, to be honest. Here we go. Let's have a look at this. The number of seconds before this session. There you go. So it is a number of seconds from now, which makes it super easy to handle in .NET. Timeout session. There you go. 1 week. So that's what the default is. Okay, so that means we're getting basically the number of seconds, right? And that means that we can do this. Public date time. Expiry. We'll make it a public getter and setter for now. So what we're going to do is we're going to go expiry equals datetime.now.add. Oops. Add seconds. Reader.read dword. Okay. So you see what we do there? The expiry basically says this is how long I want you to last. Well, we want to know the date time that represents. So we're taking whatever the datetime.now is. For those people who don't know .NET related stuff, datetime is an object that comes with the framework. .now returns a copy of a datetime value that represents right now with hours, minutes, seconds, blah, blah, blah. Followed by reader, read dword, blah, blah, blah. I had a feeling you were going to mention that, Smash. So, is it more kosher? It actually doesn't matter. The only thing that matters is us being consistent. It could be datetime.now, it could be datetime.utc now. As long as we don't mix and match. As long as we don't mix and match, we're happy, right? So we could use UTC now. And if you were doing dev, I guess that's probably what you, like in a proper enterprise scenario. The difference that Smash is highlighting here is datetime.now will be running locally. So that's whatever the system time is, regardless of where it is on the planet. So that will take time zones into account. But if we use UTC now, then it's always UTC. Yeah. Look, I think you're right, Smash. I think we should just stick with UTC now anyway. Because that doesn't move for any reason regardless of where you are on the planet. And the good thing about doing that is if the computer... This is one of the things that's actually legitimately happened, is where someone has actually traveled to a different time zone and their laptop has updated their local time zone and the session has expired. Which is kind of funny, right? Don't apologize ever for being a stickler. If you're a pain in the ass, I will tell you, but you're not being a pain in the ass. So yeah, we'll stick to UTC now because there are cases where it's not just the fact that a time zone can roll over because of DST. It could be that someone's traveling and you've popped their laptop or something. You don't want your session disappearing early because they've just traveled to the other side of the planet, which isn't cool. So yeah, we'll stick to UTC now for sure. Is there any payload you can generate with Venom which could scan the computer on the network of the infected computer and exploit them and send a reverse connection? Okay, that's kind of beyond the scope of this discussion, Devesh. You're effectively referring to something that can be automated using pretty much any tool that you've got, whether it's Meterpreter or Cobalt Strike or something. You could easily custom build that yourself. But that's really noisy, and I highly recommend not doing that. Is there a default now type used across Metasploit? That's a good question. I don't know the answer. I don't know the answer to that one. So yeah, someone else will have to answer that, or we can dive into the code a little bit later on, but I honestly don't know. Okay, so that answers that question. Let's go back to our configuration. Here we've got the UUID, which is 16 bytes, right? This.UUID equals reader.read bytes 16. Now we should actually specify a constant for this. Private static const. Do I need static? uint 32 UUID. I like making these capital. Now it's going to moan at me. Constant cannot be marked static. That's right, because it's const. It's going to be static anyway. Okay, so UUID size. And then we get the session GUID. Is that expecting an int? Yeah, it is. Alright. Let's make it an int then. And then finally, this .GUID equals reader.read bytes. Now, the difference with GUID, I think there should already be a length. Gets a 32-bit integer that represents the total number of elements in the dimensions of the array. So that should always be 16. Smash, correct me if I'm wrong. That should be 16, right? Camel case is for member variables, that will for sure. Constants, I like to use caps. To each their own. Let's see what this says. Oh, there's no documentation there. That's a shame. Let's go to the docs because I would like to know system.GUID.length. What is the string length of GUID? Oh, is that string length? I don't want the string length. Let's go to this to byte array method. Yeah, we don't want that. We actually want the methods, fields, constructors, properties. Come on, where are you? Okay, GUID should have, what are we looking for? Dot length. We're not looking at constructors. Let's look at... Why is length not listed here? Someone help me out. Why is length not listed in the documentation? According to IntelliSense, GUID.length is a 32-bit integer that represents the total number of elements in the dimensions of the array. It's got to be 32, right? Yeah, that's bizarre. Let's see what happens when we debug it. But that should be 16 bytes, right? A GUID is 16 bytes. If it's wrong, then we'll whack our own hard-coded constant in there. But to my understanding, hang on a second. There we have got system here. To my understanding, that is how it should be. It's the byte, not system.GUID. Yeah, that's what I think. So it should be whatever the underlying array length is, which contains all the bits. Yeah, correct. Line 12 is a byte array. I'm not doing anything with GUIDs because we don't actually care whether it's a proper formatted GUID or anything. We've just got a block of bytes that represents that particular identifier for the session. We're not going to transfer it back and forth from the type. We just don't care. But I do know that it's 16 bytes. But rather than defining our own constant that is 16 bytes for the GUID length, we're just going to use GUID.length as part of the framework, right? This.GUID is null. That's true. I should be doing. That's what I need to do, right? Okay, there. That's our problem. That is our problem, isn't it? I was see here. You know what? I'm gonna do this. I am gonna prefix this stuff with session because it is too confusing. There is no way of getting like the length of the GUID, but we could go GUID.empty, which is hard coded. Do we need to do that? Does GUID.empty have a length? No, it doesn't. GUID.empty 2-byte array gives us the array. Let's just, I mean, this isn't exactly a highly performing piece of code, but I kind of like doing this because we're at least sort of keeping things in sync. We could actually specify 16 hard-coded if we really wanted to. Thing I was looking for, aiming to be for the cracking perimeter exam. Oh, okay. Yeah, you won't be using that in CTP, don't you worry. Okay, Smash, yep, thanks for your help. I think you'll find OSCE a little more involved. Yes, without a doubt. If you manage to do OSCE with an automated tool, then you should probably not bother doing OSCE and go and do something like OSEE instead. So that will give us a deserialized session, right? So what I'm going to do now, we'll just duck into here. And I'm going to change this to, isn't that just horrendous? Static void session test. This actually doesn't need to be in there. Okay, so got some strange key binding thing going on here. Really, really ugly the way this is indenting. Okay, so we're going to have... I've got to put the word new in. That's probably why all my stuff is going bonkers. So we have 4 bytes for the... Whoops. So this is the socket handle. We have another 4 bytes immediately after that for the exit func. Then we have the session timeout. So we'll make that, how many seconds? We'll just make it lots of seconds. F0. Okay, that'll give us at least a... TLV stands for type, length, and value. If you have a look at the previous streams, mate, there's a bit of a deep dive into those, but Meterpreter packets behind the scenes have a type, a length, and a value, and that's how they're serialized on the wire. Okay, so we have the session timeout. Where did that go? Followed by the UUID, followed by session GUID. So, it's the easiest way of doing this. Let's just steal 16 bytes from here. How many is that? 4, 8, 12, 16. Okay. Session GUID. Sorry, UUID. And then a session GUID. We'll take another different line. Let's take this one. Okay, and then we'll go var session equals new. Actually, we'll go using. Because we know we're going to be using a binary reader beyond this. Yeah, no worries. No worries at all, man. Like, sorry, I didn't mean to fob you off, but we have covered that in some detail. So they're all recorded. Please have a watch and fire questions when you had the chance to catch up on the streams, mate. I don't want you to think that I'm just telling you to bugger off and go and watch things in your own time. We're not trying to be nasty. But the more we recoup, more we cover the same old ground, the longer this is going to take, and this is already going to take quite a long time. So, okay, so memstream equals new memory stream. We're going to need system.io, pass in data. Okay, new session. And we'll give it, oh, we need to specify the reader as well, don't we? Bar reader equals new binary reader memstream. And then we can give it the reader. Okay. Yeah, come and join the Discord, people. Definitely come and join the Discord, mate. Be happy to talk to you about all of that stuff. Oh, I need to actually call session test. Okay, so, all right, thanks. Yeah, no worries, no worries. Which reads would you like to suggest in order to follow a stream like yours? This is a really, really tough question to answer because there is a bunch of assumed knowledge, particularly around terminology related to Metasploit and Meterpreter. That's kind of assumed. Some very basic programming knowledge would be good. That would be really good. And other than that, probably if you wanted to dabble in a bit of a sort of C#, playing with C# related stuff, that's probably worth doing. We're trying to cover up as much of the basics as we can as we progress. So hopefully by watching the previous streams, you'll start to ramp your knowledge up. All right, let's see if this actually deserializes. I mean, we're not doing any rocket science stuff here anyway, so exit func should be null. Expiry is... what is datetime.utc now? Datetime.utc now is... And this.expiry is... So according to this, today, right now, UTC, it is... Is that right? 12 a.m.? No, there you go, 10:52 in the morning. And here it is it's in a couple of days' time. So that does look legit. This payload will last almost 2 days based on the number of seconds we've given it. Righto, so session UID is that block of bytes there, and session GUID is that block of bytes there, which ends in 43. Oh, did we go too far? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, yeah. No, that doesn't make sense. Session GUID. Oh, hang on. There we go, 121. We should probably view this stuff in hex. 79. Yeah, okay, cool. So nothing particularly impressive going on there. All we've done is deserialize some very trivial things. We don't have any sort of UUID specific bits and pieces that we should currently validate, but hey, it's coming. Yeah, okay, it's good that you got a CS background. If you've got some programming background, some CS background, then a lot of this will start to make sense the more you digest it. It looks like it's low level because we're actually just munging serialized packets. So when we see binary blobs and hex dumps on screen, they look kind of confronting, but they're just numbers that we're converting into different types, okay? Really? That Discord link doesn't work? Really? Are you sure? I will fix that after the fact. In fact, I'll fix it right now. Let me fix it live. I'll fix it live on stream. The Discord link. Copy. And paste. Thank you for that. Okay. Let me just submit. Okay, Discord link should be fixed now. Sorry if I had that incorrect. So what are we doing today? Okay, today we are getting to the point where we are starting to wire in from the first point, assuming that we've just established a connection from a compromised application or host of some kind. That's connecting back to Metasploit. Metasploit has served up the first stage. We are in the process of deserializing it. which is a little bit arse about face, because by the time we actually get to this point, we have already kind of been bootstrapped in some way. It is a little bit confusing. But remember, the first stage that comes down the wire after the initial connection is the DLL, which is metserve, which is the thing we're currently building, followed by a configuration. And so once this piece of code is running, the configuration is then deserialized. Right? So that's what that... Well, basically what we're doing is we're starting with the deserialization of the session information. Okay? And that's based on what we're seeing inside the source. Okay? You can see that we have a session value that's actually deserialized first. Then, once we've pulled the session configuration out, we have to go and pull out all of the information for the transports. Okay, now you'll see how for every single transport that we find, we've got to create a transport block. So we actually support, in the configuration, we support multiple transports. We just don't actually parse that. Sorry, we don't actually have the facility to specify multiple transports when we generate our payloads, unfortunately. That's a bit of a limitation of Metasploit at this particular time. But as you can see here, this transport block will actually vary depending on the type. Okay, so for every single transport that we create, we generate a string. Okay, that string will look something like this. It will be TCP foo.bar.com 1234. Okay, so that basically says we're using a TCP, reverse TCP connection. We're connecting to foo.bar.com on port 1234. If we do this, what we're saying is we're doing a bind TCP because we haven't specified the host that we're connecting back to. Okay? We can also do TCP6, right? Which will... God, using Notepad is awful. I should have fired up Vim. That's the same as saying we want to use IPv6, right? And so this will actually do the same with bind, okay? So that's a reverse TCP for IPv4. Well, when I say IPv4, it will actually try and use both, but 4 is the fallback, and here is forcing 6. Anyway, we'll come back to that later. Then there's HTTP foo.bar.com port number, which also has a URI, an LURI followed by a massive blob of stuff. But this piece here is, this last bit here is generated based on the UUID. So HTTPS is the same. Now obviously if HTTPS and HTTP are specified with no ports, we will default to the standard 80 and 443. There's also pipe, which basically says hostname followed by pipe name. So that basically means that if there is a SMB pivot point sitting in your network, then the host name is where you go to connect via SMB, and pipe name is the name of the pipe listening on that host that you're gonna pivot through. All right. What other transports are there? I think that's pretty much it. HTTP, TCP, and pipes. Now we don't actually at this point, I think, support pipes in here. We have HTTP and TCP. Okay. So what we need to be able to do now is we need to effectively deserialize based on the transports that we're pulling out, right? So when we generate the scheme, you'll see we create a URL on the fly. There's even the scope ID for IPv6. The transport URI is for HTTP. We need to add a stack of other stuff. That's right. So if we have a TCP transport, then... No, Jay, I'm not seeing any frames drop. Can anyone else see it? You seem to have some regular problems with that, don't you? Which is a little bit annoying. Anyway, so these are the kind of transports we're going to see. In the case of these HTTP ones, remember the configuration itself is going to have like quite a few other bits and pieces. It might have a user agent, proxy config, so that is like user, pass, host, port, etc. All of those sorts of things. No UDP at this point. We don't have support for transport over UDP in Meterpreter yet. It's still on the list of things to do. We just don't currently have it. But when it happens, we will just add UDP or DNS or something like that as a transport type, depending on what it is that we're using. Okay, does that make sense? Anyway, so this is where it's going to get a little bit trickier in .NET land. Because if we have a look at the C implementation, let's go to server. I don't know exactly where it is. It might be in server setup. It might be in one of these puppies here, server transport. But what I'm looking for is here. So see how we've got this create transport function. So create transports is invoked by, let me just find it. So you see here, this is where we're parsing the configuration. Okay. We get the expiry time, start time, expiry end. So these are things we're going to have to deal with very shortly anyway. So config points to this metserv config, which is the serialized configuration, right? So we've got config.session.expiry. We keep track of some metadata here that says when did we first start, and then we do some math to say this is when we should finish. Okay. Then for each one of these things we call create transports at this point. Okay, so you'll see that we then kick into the mode that pulls all the transports out. Okay, so create transports. First part of the transport is always the URL. If it's null, then we're done. Okay. Apart from OJ. Maybe these would be PRs. Well, feel free to go ahead and create DNS, and like there are people who have already started working on this stuff. It's a very complex beast because like Meterpreter has a fairly verbose mechanism for communication, right? And sending data across DNS is slow. Regardless of the method you use, it's slow. So how do you encode staging and all that sort of stuff over DNS? I know Cobalt Strike does it, but it's slow. So, you know, there's pros and cons, and so far we just haven't got around to doing it. Now, so here, as you can see, first thing we do is we say, right, go and create a transport based on the current status of the transports that we've passed in. Now, this metserv transport common is just like a container type that specifies something, but something that's important. Almost 2,000 text requests to stage a CS beacon over DNS. There you go. That's huge, and it's painfully slow. Thanks, Rasta. That's a really interesting statistic. So, create transport. What's the first thing we do? See how first of all we say, what are the first few characters? Is it TCP? If it's TCP, we're going to go and create a transport that matches TCP. If it's a pipe, we're going to create a name pipe. If it's HTTP, we're going to create a HTTP transport. So what we need to be able to cater for is the case where, let me take you back to where we were. Now you see this, this metserv transport common. I'm going to show you what that's defined as first. So just bear with me, because this is important information. Here we go. So, we have a maximum URL size here. Okay? And the URL size is 512 characters. So there is a block of 512 characters whether you like it or not. Alright? So, first thing we're going to do, now that we're dealing with transport related stuff, is we're going to add a new folder, and I'm going to call it trans. Okay, and then we're going to add a new item called now, because this is effectively metadata, one of the options that we could have is to create a hierarchy of classes, which we'll probably end up doing in some way, but we're going to have a configuration object that knows again how to deserialize itself, and then we will give that to the respective transports in order to continue to deserialize themselves. Okay, so we're going to call this a, what is it going to be? We'll call it a transport. Yeah, we'll call it a transport config for now. Okay, we can change this later on. So what we want to be able to do is go public transport config, and we're going to get a binary reader again. Oops. Okay, get a binary reader again, which means when we get to this point, we're actually going to change this to config test. Okay. Now, it probably means we'll have to generate some config on the fly, or maybe we can extract one. Maybe we can generate one from Metasploit like we did with the other stuff, and have that spat out. We'll probably do that in just a minute. Okay. So we get a new session, then we're going to go var trans config equals new transport config, and we're going to give it the reader. Okay. Now, as we saw with the base, we have a transport config common which contains the URL, which is 512 characters. Okay. Now we're going to be supporting wide string formats here. Okay, so 512 characters. See how it says char type, URL size. So our char type is going to be wide string, which is 2 bytes per character. Okay, so that means we need to be able to go reader.readString. Nope. Is that we need the extensions using met.core.extensions. Okay, extension int length. So we want to read a string of so many bytes, right? If we go to the definition, oh, not that one. Binary reader extensions. Ah, look at this. I should put this in its own class. My bad. It's finished. Read dword, read qword, read string, int length, get string, read bytes. So the number of bytes that we give it is not the length. Maybe what we should give it. So when we specify a string, we want to say how many characters are we reading. No, we don't. We want to read however many bytes there are. Yeah, so we'll leave it as is. So we know that as a result of there being 512 characters and private const int URL size equals 512. Oops. We know for sure that we're going to be dealing with wide character strings. UTF-8s, so we want to read 512 times 2 bytes. Does that make sense? Public string URL get set. Does that make sense? Okay, simply translates it here. Maybe there should be a read wide string extension. That's a good question, Mongo. Let's revisit that. Oh, and hi, by the way. Let's revisit that because that is interesting. You see, the thing is, the reason why I say wide string right now is because when dealing with HTTP transports, we use wide string, but with TCP, we don't. which is shithouse, isn't it? I think it's definitely going to remain wide string. For now, I'm going to leave this, but what I'll do is this. Note, we should consider supporting ASCII and wide string strings. At the moment, this assumes ASCII. So what I'm going to do is I'm going to keep that as an ASCII string. And we will readdress this later on. We may find that with our .NET related stuff, we might just by default always use wide string, which we'll probably end up doing, and we'll revisit that in a minute. Excuse me. Okay, so once we've read that, as you can see, we have a communications timeout. The number of sessions to wait for a new packet. That doesn't make sense. The number of sessions to wait for a new packet should be seconds, not sessions. So we have that. We have a public uint32. Ugh. That's so irritating. Uint32. I don't like the way that these things are rejigging. Comms timeout. Get set. And then this .comms timeout equals reader.read dword. Not double, dword. Thank you. Okay, so we get the comms timeout next. Then retry total and retry wait. Okay. Retry total. Wait. It's definitely a keybind issue that's killing me. Retry total equals reader.read dword and wait. Okay, so that's effectively our core functionality. That this configuration here applies to every single type of transport. Okay, so if we were to do this at the top level as per this, right? What we now want to be able to do, once we've created the transport config, is to create the transport itself. So we should be able to do something as simple as like transport equals transconfig. Actually, no, we don't want to do it that way. So here's the problem we've got. We need to look at the string. We need to look at basically the string that is passed in as part of the URL and have a look at what the first part of that looks like. So if we were to cheat, we could put this into, it would be nice to put something a little smarter into this, hey. So if we did something like public iTransport. Yes, we're going to have some interfaces in here, I'm sorry to say. Create transport. Now we're going to need an interface. Public. Yes, I know. You're already hating on me. Ah. So we have an iTransport. Ooh, first interface. I hate your face, Smash. That's a classic dad joke from someone who doesn't have children. But well played to you, sir. Well played. Please leave the stream and never return. Alright, so if we had a public TCP transport, which is an iTransport, I also need to specify that it's a class. Hey, let's move that to another file. Create transport. So then what I should be able to do is something filthy like this. Switch. We're going to go this.url.split. Because I am filthy and I am not sorry, and we're going to take the first one and we're going to lower that. So that basically says split on the colon, which will give us the scheme right at the start. So that split will return an array. We're going to say index the 0th element, so the first element in the array, which will give us either TCP or HTTP or HTTPS. We're going to make sure that that's to lowered, and then we're going to go case TCP. And if it's TCP, we're going to do a thing. It's default. We're going to return null. What have I done? There we go. Don't need this. We actually need to go return new TCP transport. And we're going to give it our own config. What have I done wrong here, boys and girls? Doesn't contain. Do I need to just rejig this so that it looks good? There we go. That's the problem. Public interface iTransport. Well, let's get our TCP transport out, and we're going to say public class TCP transport. We're going to take a transport config. Class. What am I talking about? Transport config. And we're just going to retain it for now. Okay, so we can reference that a little bit later on. Now, we want to know a few things based on this transport, right? We want to be able to say what is the retry weight, the retry total, etc. But we basically want to return like a read-only copy of the configuration, right? But for now, I'm just going to expose the configuration as is. So we're going to say public transport config, and we're just going to expose a getter, right? It's not? Why isn't it? Oh yeah, of course it's not. We just need to specify that this interface needs to have a config element on it, which means we need to implement it here. Ah, man, that's not what I want. So bad. Let's go public transport config. We're going to make it a public getter and a private setter. And then seems like an abstract base class might be a better fit. I agree. But what I like to do with this first is just get an idea of whether or not there's enough commonality to justify it. If all we're dealing with is a single property, it's probably overkill. So for now, I'm going to stick with an interface. And then collectively, if we think that it makes more sense because we see more functionality than a single property get stored, then maybe we'll bump it up. But we'll start with an interface. I had considered that too, Mongo. And this is the juggling, right? I mean, do we deal with interfaces? Do we deal with abstract classes? I like to start with interfaces, and then once I've got this sort of core of the functionality together that maps a reasonable subset of the classes that we're going to have implementing those interfaces, then we can go, okay, here's a good chunk of common functionality. Let's just push that up, and we can push that into an abstract class. So we will end up having other stuff too. I'm not being a jerk, by the way. I just thought I'd share. So anyway, if we have... see, what is with this bloody carriage return line? I wonder if it's something to do with the way VMware's being a douche or something. Yeah, I don't know. We'll see. See, it's doing it all the time. Alright, bugger you. Seems to modify the line endings for this constantly. I wonder if there's a clash of plugins or something similar. Anyway, so if we have a TCP configuration, we go and create a new TCP transport. This may not matter if we only ever send lowercase from SF, but switch statements should use to lower invariant. That's a good point. That's very true. So for those people who don't know, .NET string to lower. So you'll see that the toLower method. So the toLower method basically says use the effectively whatever the current culture I think is. Let's have a look at the remarks. This method takes into account the casing rules of the current culture. This method does not modify the value of the current instance. Instead, it returns a new string, which is fine. But you'll notice here, the casing operation that results from calling toLower takes the casing conventions of the current culture into account. If you need the lowercase or uppercase version of an operating system identifier, you should use toLower invariant or upper invariant because that produces the same result in every culture. Okay. Now, in our case, this isn't going to be a problem because all we're looking at is the scheme. But to maintain a habit for now, for things that actually matter based on hard-coded values, we will use toLower invariant. So it would affect the pipe transport in Turkey, would it? Oh, there's a few. It's not just Turkey. There's something else. There's a few other cultures where you basically end up screwing yourself, and there's a bunch of CTF challenges and whatnot around this stuff as well, which is kind of funny. So we will support TCP. Eventually, we'll support TCP/6, but to begin with, we're just going to start with TCP. So what I'm going to do is I'm going to probably in a minute generate a configuration block. There you go. What's wrong with Turkey? Thanks for the link there, Smash. Anyway, so if we take a step back now, so what I'm thinking of doing is actually just popping one level higher back up to the server, because like I said, we have a session which we're not currently using. If we have a server constructor, we're going to need to create a new session, right? So this dot session equals new session, and we're going to have to give it a reader of some kind, right? Now the assumption here, if we're being loaded as part of a stage, then we're going to probably going to get two different things. I'm trying not to get ahead of myself because I know behind the scenes we're going to stumble on a particular case later, but I've got to pretend that I don't know that. Okay, so we'll come back to that. We're going to get a reference to a binary reader here as well. Alright. We might even make that read only, so that the session itself can't be. Whatever. No. Private. No, I'm not going to do that. I'm just going to leave it like that. So session equals, because I only want that set once. And so when that's actually properly deserialized, then whatever the current transport will be. So we need to be able to loop through transports effectively. So in order to load all the transports, I'm going to put this in a separate function, load transports from whatever reader we give it. Okay. So while reader.peakchar doesn't equal the null byte. Now remember, see how, hang on, where was it? It was in here. Create transports, plural. So see how, like, while it's not the null byte, so we're looking effectively for a null terminated string, basically a string length of 0. The null byte here basically says that's the end of the transports. Okay, oops. So while we are not at that point, we need to be able to go bar transport config equals new transport config. Give it the reader. And then this dot transports dot add, oops. Transport config dot create, no. Transport config dot create transport. Okay, and that means in here. All right. Public, no, private. Let's just do that. Private list of transports. Okay, so we're basically looping through whatever the transports are, and we're adding more and more and more transports along the way. Peak char returns a byte, or effectively an int. Yeah, I could change this to 0, which is basically the same thing. But we're actually dealing with bytes at this point. Okay, is there another peak? Or is it just char? Yeah. Let's leave it like that for now. Peak char basically says, look in the stream and have a look at the next char that's coming off the wire. It's what we're using to also detect whether we've reached the end of our byte stream. There be dragons in here. Smash, at the same time as what you're saying is definitely true. These are the kind of dragons that well, this is the thing. Does it pull out 2 bytes? It doesn't pull out anything. It pulls out a value that returns it as an integer. And what I want to have happen is for this to break while we're debugging so that we can all understand it. If that makes sense. So it might come back as 0. How many bytes is it pulled off? Is it single byte? Is it 2 bytes? Don't know. I actually think it only pulls a single byte. But let's have a look. Let's go and look at the documentation. Peak char. Oh yeah, definitely. There are known issues that we're going to face that I want you guys to see on screen break so that we can fix it. So, current character cannot be decoded into the internal character buffer by using the encoding selected for this stream. Exactly that. Yeah, I've learned something too. So it's very, very tempting to get ahead of ourselves, which, you know, is good and bad, but I was kind of hoping that we were going to get bitten by this. So what's happening is that pretty much across the board, when we're specifying the binary reader, we should also yes, thank you, sorry, Jen. That should be, thank you. We should probably also specify the encoding for the reader. Correct? Which is not something that we've done. So this reader here, it uses UTF-8 encoding. Now, this is why when we were talking about wide strings and whatnot before, I was like, you know, let's just leave that. Let's just leave that and see what happens, because that's going to force us to understand the guts. So I was kind of hoping that this was going to bite us and that we were going to fix it after the fact to show that development is hard and that reading the documentation is something that we should be doing. But Smash likes throwing this in our faces as we go. Excuse me. But I'm going to pretend that he hasn't. But everyone else, keep that in the backs of your minds, because it may well become an issue. It actually really only becomes an issue past... what am I looking to say? When we're dealing with strings. And you'll notice that we're actually dealing with strings ourselves. We're not actually calling read string. We're calling our own implementation of read string, which extracts the bytes. Okay, does that make sense? If instead, like if we had sort of variable length encoded strings, which we may well have coming up, then we're going to end up in a slightly different scenario, and we need to decide whether we're going to deal with always wide strings or not always wide strings. We will be using wide strings, just so you know, but for now we're just going to assume ASCII. So that's basically where we're at. Okay, so let's do this now. Instead of doing that, we're going to go server equals new server from this reader. Don't even know whether this is building at the moment or not. Build starting. So that loads the stuff out of the session. Session good, expiry, exit func, whatever. Now the exit func we may not end up using, but we may use. Just not sure at this point. Wow, we're already an hour and a half in. Can you believe how fast time is going, hey? It flies when you're having fun. So then we want to go load transports from the reader. Now at the moment we don't have any transports. So what I'm thinking of doing is ducking over to our local Metasploit instance. And what I'm going to do is what was it? Generate transport? No, generate config. Now I'm going to pull it out of Meterpreter. No, not there. This one. Copy this. Alright, so see this generate config here. This is the one that we were looking at before, right? Standard error dot puts x dot inspect x. Now, if we do this, MSF Venom payload Windows Meterpreter reverse TCP lhost lport 4455 raw. What happens? It should spit out some nasty ASCII crap on screen. But I'm hoping to see the config that's generated. Oh, what do you mean invalid? Oh, there's another R in Meterpreter. Now what I'm going to do is redirect this to dev null, because we actually don't care about the result. I only care about what's written to standard error. Why didn't that work? Oh, hang on. Maybe it's because we need to stage. Yeah, that's what we need to do. I need to stage it. Okay, so let's actually write this to scratch stream met.exe. Instead of that, we're going to put 192.168. You know what? I don't even need to do this. MSF console dash QX. We only want it to stage or attempt to stage, right? Use multi-handler set payload Windows Meterpreter reverse TCP set L host 127.0.0.1 set L port 4455 run. Now, yeah, I hate it when it does that. Yeah, we know we're binding to loopback. That's okay. We know what we're doing. We're professionals. So, now if I do this, nc localhost 4455, there it is. Right, so this is the config block. That's pretty cool, hey? There's a lot of nulls in there. Now, the config contains a bunch of other bits and pieces, but that's effectively the config. There's a lot of nulls in here. So, let's take a copy of that. And I'm going to drop it over in this little test area here, right? Actually, what I'm going to do... Whoops. What did I do? What did I do? I'm going to quickly duck into some Pythonage first, because I have a couple of handy one-liners that I like to use. Just a second. I think I've shown you these before. So let's take this. And this. So what I want to be able to do now, once I've taken this information here, copy. I'm going to go x equals that thing there. Now we should easily be able to do the byte array format one. So what am I looking for? I lost my nifty little doohickey. Might have missed this in the early part of the stream. So wait, the config doesn't use TLV format. That's correct. It's correct. It is not encoded. It's not encrypted. This is pre-staging process. So we're not even able to parse TLVs at this point. We don't even have metserv running when this code is generated. Okay, this block will actually be suffixed onto the DLL that goes across the wire. But what I actually want to do is change the array. So instead of A and giving it the key, I just want to give it the data and the size. So instead of this chunks of... actually, you know what? I am going to do that. Let's give it the XOR key of null. Okay, that's the key. The data we're going to give it is X, and the size is 16. Winner. Let's print that. So that gives us the config block like so. Now we can take this and drop it in here. Ah, you jerk. There we go. So now we have a config block that we can play with. Oh, come on. Auto-formatting would be nice. Yeah, sorry, I didn't really make that very clear earlier on, and I should have done. But the config and metserv go side by side over the wire, so none of this is encrypted or encoded. Okay, so going back to our server, we should be able to pull out a transport now. Let's just see if we get bitten by our encoding issue. Transport config reader. Okay, so we should pull out the URL first. What's it gonna look like? Can anyone take votes? Ooh, it's messy. That's pretty gross, isn't it? So that might mean things are royally screwed. So just give me a second. Let's go back to here. So when we pull in the exit func, what does that say? Exit func is null according to this. Expiry. What is this expiry date? 26th of the 4th, 2147. Wow. Hey, Archbishop, thanks a lot, buddy. You have a good night, man. We'll catch up again soon. Thanks for your time. Always appreciate you coming along, man. Okay, so that basically means that the parsing of the session, of the stuff, I should say, here is not what we were expecting. What I should actually validate is, as part of our payload here, properties, server, program. Let's have a look at the first few bytes. 000000000 F0 B5 A2. So going back to our F0 B5 A2 V80. V80. So this is definitely correct. So it should be taking 1, 2, 3. These are 16 byte blocks, right? So, pardon me. We should be seeing 4 bytes for the socket handle, 4 bytes for the exit func, and then we've got, what is it? 4 bytes for... Sorry, give me a second. So that's definitely 0. Expiry. So the expiry, that doesn't seem right, does it? It's getting easier to follow along. That's awesome, mate. We're going to start wrapping up very shortly once we've just figured out what this little issue happens to be. Okay. So let's go back to our session for a minute. We read the D word first, which we know is 0, right? What I'm going to do is this, set next. I love this, sex next. We can skip that. And in this immediate window, I'm going to go reader.read D word. If I could type properly. There you go, it's definitely 0. So then the exit func that comes out should be null, right? Now, if we read this D word, which basically says return uint32, our expiry is definitely a long way into the future. So the question is it packing that integer as we expect it to, which it's got to be doing, right? Like when we actually looked at the code of this, in this browser window, in here, when we generate the session block, we go 0, exit func, expiration. 1, 2, 3, V. So when we pack a V, that's definitely... Oh, hang on. Look at this. Can anyone tell me what I've done wrong here? That's a Q, not a V. Which means that isn't 4 bytes. It's 8 bytes. Yeah. Of course it is, because we've got to deal with 64-bit handles for stuff. So, my bad. But that explains the problem nicely, right? So it's not a D word. Oops. Let's go stop. It's a Q word. Interesting, hey? Let's see if this makes a difference. Right, so we read a keyword. D word should still come out 0. Oh, and that exit func, of course. Exit func is set by default to exit process, unless said otherwise. It could be exit thread func, actually. Thread, I should say. Exit func thread. Let's see what the expiry looks like now. It's still messed up. Bit alignment is such a hassle, isn't it just? But as we can see here, the date here is still messed up. Like, that is a long time into the future. So let's make sure, again, oops. Expiration is the session expiry, and we are doing V. So I'm pretty sure, unless we're not supposed to twizzle this, which wouldn't make any sense. Or maybe it does. Maybe it does. If instead of read D word here, we go read uint32. Let's see what happens. Well, it looks like we're not doing any byte swapping, etc. There it is. So when you pack with N, that does the network to host order or host the network order. And so when you unpack N, it's basically doing the little endian, big endian swap, whereas V doesn't do that. Let's look at the Ruby documentation. Ruby pack string. What the pack array array.pack. What we're looking for is, here we go, integer directives. So can't really search for V, can I? It's going to be in here somewhere. V, here we go. Little endian byte order. Okay, so we just need to leave it as is. Why that isn't big endian? Because there are so many other cases where we are using N, which puts it in network byte order. So that's it there. It's another nuance. Another little thing that we've got to worry about. But at least we know, right? So instead of reading uint32 there, we need to do the same here, uint32. Let's see what happens now. Exit func. Expiry looks legit. Read bytes. Session GUID. Okay. Let's see what this does. Peak char comes back with non-zero. So transport config. What does the URL look like? Ooh. T, C, and then P with all of the nulls in it. See that? So, what do we need to do here? Yes, it's a URL, exactly. It is definitely a URL. Because, yeah, look. We can see that it's got TCP : whack whack and it's got 127.0.0.1 in it, which is exactly what we want. But that's not how we want it, right? So instead of read string, what I'm going to do is I'm just going to read bytes instead. Oops. Reader.read bytes. I just want to have a look at what this comes out like. So we can see it in its rawest form. So you can see it's definitely wide character strings, right? Now if it's wide character, we should still be able to get it using the read string function, right? Let's just go in here for a minute. Where's the call stack? Yeah, so this is exactly where we are. Read bytes.length for trim end. Okay, so how about we do this? Let's go var s equals reader or read bytes, and then in here we'll just put just put s. This will give us the ability then to play inside the immediate window. Alright, because S should be a block of horrible looking bytes. Okay. So if we go encoding, sorry about the size of this, by the way, there's not really much else I can do about it. Dot get string from these bytes comes out like that. I wonder why. It doesn't? Oh no, it doesn't. It'd be Unicode, wouldn't it? Get string. There we go. So wide character would be Unicode. Alright, Mongo. You win. I knew you'd love it. Such a jerk. Such a jerk. Ugh. Oh, hate all of you. Now I'll need to check to make sure comms, retry, and whatnot actually are D words. All right, is the URL right? No, it's not. We need I just restarted it, and I didn't change this to read wide string. There it is, TCP 127.0.0 and blah blah blah. So that's all good. That's really good. G'day Barney, thanks for coming in, mate. You're a little bit late. We're about to bail out. Let's see what the comms timeout looks like. 0, retry total, 0, retry wait, 0. That's not correct. So the question there would be, why are we not reading the rest of the configuration correctly? Some of us have worked, yeah, a likely story, mate, a likely story. So, where's that transport config thingamajigger config block for every transport? Session expiry. For every transport block we have the URI. Ah, look at this, we've got the V's again. Transport URI is HTTP payload, we need to stack on other stuff. Yep, so that's the pack. So com timeout is, they're all packed with V's again, so we don't need to do the D word thing. We just need to do the uint32 thing. But that's not gonna, that doesn't actually solve the problem for us. We have a new follower, Lorem Dreams. Thank you for the follow. That's wonderful. Sanity checking, does a 512 array size refer to bytes or wide bytes? And are we using it correctly? Well, now we're not. Because we're doing wide strings, we do need to double it, right? So instead of doing it there, I'm going to specify for a wide string, we're going to read twice as many bytes. Oh, well, there's our first get system reference for the night. Took a while, pretty much right until the end. So there you go, we've got our URL. Comms timeout now should be, there you go. Let's get rid of hex display. Comms timeout is 300 seconds, retry total 3,600 seconds, retry wait 10 seconds. That's much better. Is there a distinction between Unicode and UTF-16? Yeah, so Unicode kind of means it can be a conglomerate. It's like, yeah. I don't know enough about Unicode, but what I can say is that there's apparently a really good post, which I've read, and I still don't get it. Isn't Unicode effectively like a variable length? Isn't that what that means? Anyway, what I didn't do, this is the last thing I'm going to do as part of our test. Yep, variable length. So it could be all three, which is horrible. Anyway, so we're going to load the transports. We load a transport config that's legit, and in here we are now going to check TCP, and we create a TCP transport. Ooh, object reference not set to instance of object. Of course it's not. That's because I haven't done the sensible thing. Private server this dot transports equals new list and this. So here we go. So our transports should have one transporter in it, which is a TCP transport. Fantastic. Okay, so we're going to wrap things up now, but what I'd like to highlight just briefly for us to consider next time is this. So our server at the moment, we have the ability to load from a binary stream, which is what we're going to be passed in, okay, once the mechanism has been bootstrapped. But here's a really important thing to note. When we have a TCP transport, we already have a socket that's open, okay? So the stager kicks off, it connects back to Metasploit, and it pulls down metserv and the config. And then we reflectively load metserv. In this case, we'll just do like an assembly load style thing. And then we're going to pass in a binary reader and say, go and read the configuration from here. The important thing that we need to be able to give it at that time is a handle to the TCP socket that we're using to do the original comm so that we don't have to create a new one. So as part of this bootstrapping mechanism, we need to find a nice way of bubbling that down. Okay? So have a think about how we might be able to do that. So I have an idea. Anyway, it only really matters for named pipe transports and TCP transports when we have that or that handle sort of sitting there. So anyway, look, that is pretty much bang on our 2-hour mark. So I'm going to wrap it up there, given that we've kind of got the ability to half pull apart some configuration and we're sort of well on the way of, to being able to do more. I'm going to leave everything we've got sitting as is in these virtual machines, and we will kick this off again in another 2 days' time. So thanks to everyone for tagging along as always, and thank you for the suggestions and the really good discussion. Like, seriously, I know I'm the one coding, but having you guys in here talking about it, it's not only showing that you're paying attention, but you're coming up with your own stuff, and it's really useful, and I'm very, very grateful. So thank you as always. This has been the 7th stream now, so hopefully after this I should be able to officially be a Twitch affiliate, which is really exciting because we can have more fun with stuff. I don't know what it means yet, but that'd be cool. So, but yeah, it's been really good fun, and I appreciate you letting me have a brief hiatus yesterday. But in the meantime, as always, jump in on the Discord, fire off your questions, keep the chats coming. I really am enjoying this. It's good fun, and I appreciate your company. So I don't really have any magic messages to hand off with like I did last time, but maybe I'll just state again, look after your friends. They need it. So until next time, thanks again. I'll see you in a couple of days. Ciao.